So I'd like to welcome everyone today to the Java Architect panel, where it's your opportunity to ask the Java architects questions. Many of you are familiar with this format. We typically do this live in events, and we take questions from all of you to give you a chance to connect with the leadership here on our Java team, to ask them the hard questions that you have in many situations. And so we're trying to do this online here live with you today. To prepare for this event, we also took some question opportunities in advance, and many of you sent in questions for our panelists. And obviously, we also want to be able to take questions from you today as well. So please make sure to use the Q&A icon to enter your questions. We'll try to get to many of them as we can. First off, I'd like to welcome our panelists today, our Chief Architect of Java, Mark Reinhold, our Chief Language Architect, Brian Getz, and two of our leading developers on the JDK team, both Ron Pressler and Mikael Vidstedt. I'd like to welcome all of you. And with that, when I was looking at the questions that we got online in advance of today, there seemed to be a common theme. And so here's one of the more popular ones that seems to be very common. One is, aren't you exhausted with the 6-month release cadence? Isn't that taxing for the Java team? And then there was a follow-up, which seems to be tied into that. I'm still a bit confused with LTS versus non-LTS, which is also very interesting, but worthy of answering. Maybe that first part in terms of just the sheer exhaustion. Are all of you tired? Maybe Brian, you want to take that one.
So, funnily enough, it's actually the opposite. When we started with this 6-month cadence a couple of years ago, everyone thought, oh, you guys are insane. You're never going to be able to turn it around that fast. You're going to get eaten by the process, etc. And it's turned out to be quite the opposite, that we haven't actually, or we didn't think we were actually speeding up the rate of innovation as much as the rate of innovation delivery. But we were very worried about the process overhead. And what we ended up doing was we were able to strip down the process quite a bit and enable our developers to spend more time developing and less time going to release meetings and what have you. And the result is it's actually less tiring. If you could imagine what it was like when the train was only leaving every 3 or 4 years, in the weeks leading up to the train leaving the station, it was a mad rush of all hands on deck. Compromises had to be made and people worked ridiculous hours, and it was a very stressful time. And now, most of the time when we have a release going out, I don't even know what day that's happening, because everything is just working and we're all just working on the next feature that, that we want to ship. And as a result, the predictability has been good for everybody, but it's also taken a lot of stress off the development team.
So before we get into the LTS question, I see a question here in the Q&A, which is interesting. So what does that mean for features? When do features get released? Maybe Mark, you want to touch a little bit about what that means in terms of releasing new features?
Well, as we often like to say, we ship features when they're ready. We don't ship them before. Another one of the big drawbacks of the 3 to 4 to 5 year cadence was there was a strong motivation to tie features to a specific release, especially the big headline features like generics or Lambda or modules, whatever. And then those things would cause, those things would slip, which would cause the releases to slip. It was just a horrible way to live. So now we work on features. We don't promise that they will be done in any particular release. When they're about ready, we ask the question, well, is this feature about ready? Oh yeah, it's looking like, yeah, that's pretty close to ready. We look at where we are in the current release cycle and okay, put it in or don't put it in. If the feature is not quite ready and it's, just a couple of months before code freeze, then you wait until the next one. And, the next release is only 6 months away. So it's really not that big a deal. To reinforce what Brian said, it's just amazing the difference between the stress we had before and the stress we had now. It's like, oh, every 6 months there's a release, and oh yeah, which day? Oh yeah, it's that day. Okay, cool. And in the last month or so, yeah, a couple of showstoppers might come in on a release candidate. People sit down and fix them and work through the issues, and it's just night and day.
It's been a pretty amazing just continual train. If we look at where we're releasing Java 15 today, and if my math is correct, it's the 6th release as part of the 6-month release cadence. And if my math is also correct, if I do the sum of all of the JEPs at least that have been released between Java 10 and Java 15, it's starting to look very close to one of those releases that happened every 3 years. So to me as a developer, getting innovation incrementally seems to be a better approach to my development life. I mean, it's just much more approachable and predictable. So yeah, testament to the team and all of you. Ron, maybe you want to touch a little bit on that second half of the question that seems to be rather common in terms of, I still get confused on LTS versus the non-LTS. Help me. So where do we go from there?
So LTS is a service provided by various companies, including Oracle. OpenJDK itself does not have the concept of LTS. All versions aren't created equal. And for most companies and most people, I think it's best to just use the current version. That's the simplest, easiest choice, the default choice. In some cases, companies can't. Part of it is because I think this process is new and the ecosystem hasn't adapted yet. So some libraries perhaps only support old versions. And if you find yourself in that situation, then LTS is a great choice. But otherwise, just use the current version. It's the safest choice. It's the fastest choice. Just do it.
It's interesting because for a long time, we were receiving a lot of feedback. You're moving too slow. Can you accelerate? And now we're moving at the pace of innovation that modern app dev requires. And it's, oh my God, I think you're moving too fast. But I think the comment now is you're moving at a pace that I can absorb. And it's also interesting if you look at like the IDE space. I mean, JetBrains has, with their IDE, have 3 releases a year. So, tooling seems to be catching up. Frameworks and libraries are catching up. And another question here, which is kind of tangential, is, so what tools do you have to help me in terms of being able to keep up? Michael, maybe you want to touch a little bit about, from a tooling aspect, what's there in the JDK that can help developers?
Yes, so we do have a couple of tools that we have developed over the years that can help you identify things that you are maybe depending on that in the future we have changed in some way. One of the key things we did in JDK 9 was to hide some of the internal APIs that you really shouldn't have been using to start with, right? And there is a tool explicitly to look at things like that. So which APIs am I using in my application? Are some of them maybe ones that I shouldn't be using, right? And back away from that and try to use something else instead. So we have that. And the other thing that we have is we are deprecating things over time, right? So in some cases we have functionality that maybe it was a good idea at the time when we introduced them, but over time we chose to go another way, and that functionality is deprecated, and in some cases removed, not always, but in some cases. So we also have tools to look into what kinds of APIs you're using that are deprecated going forward. So there's JDepR and JDepR, for example. JDeps. I'm getting it wrong.
JDeps.
JDeps, yes, exactly. Both of those tools, they live in your Java Home bin directory, and you can run them on your application and get very powerful and helpful advice on how to move forward.
Yep. Brian, yeah, any thoughts on pipeline?
Yeah, so one of the real hidden benefits of the 6-month release cadence has been its effect on the feature pipeline and how we plan features, right? So when we used to do these big bang releases, we picked a big feature, generics, lambdas, modules, and that's all anybody worked on for the 3 years that that release ran. And the unintended consequence of that is that smaller features just got crowded out. There was just, they never managed to like bubble up to the top of the priority list. So things like local variable type inference, which we did in 10, was, something that people had asked for many years before, and it always seemed like a reasonable feature that just never got enough attention. And, so the 6-month cadence has given us a chance to balance a better mix of small features and bigger features, and also to reprioritize the pipeline as new information, comes in, as we learn more about features. So the accidental result is not only are we getting a better mix of features, but our feature pipeline is better than it's ever been, because we're constantly working on some things for the short term, some things for the medium term, some things for the long term, and that wasn't happening under the old model.
Yeah, that's actually a good segue. So another question that seems to be very popular, and it's also coming up in the Q&A, is, I'm still on Java 8. Why should I migrate? That is a common question we hear often, but it's always good to be able to address that. So what's the incentive to move off of Java 8? I'll throw it to you, Brian.
So, Java 8 is like 6 years ago. Right? Java 8 was an amazing release in its day. It had big new language features. It was, it really made a big statement about Java is back. We kind of went through maybe a darker period, in the years prior to Java 8, and this was definitely a statement that, it's possible to teach an old dog new tricks, and people love the Java 8 features. But the world has kept moving since then, and we've kept improving, improving the runtime, improving the platform since then. And, 8 was a great place to be 6 years ago.
Mark, any thoughts on that?
So I think people often maybe just aren't aware of all of the improvements that we've made since 8 that you can leverage without even having to change your code, right? Assuming your application, your libraries, whatever, aren't using the internal APIs that we started encapsulating in 9. You should be able to take an 8 binary and just run it. You can benefit from better runtime compilation. You can benefit from better garbage collection. The G1 workhorse collector has advanced considerably in 6 years. You now have the option of ZGC for very low latency scalable garbage collection. And there are all sorts of improvements across the runtime in the libraries that you can just get by moving from 8 to 15 as of today.
Yeah, one thing that is worth reminding all developers is this isn't some big sort of ceremonial situation. We go through these patterns in history. When Java 6 end of life, there was this mental crisis. Oh my God, I have to shift to Java 7. And then when Java 7 end of life, oh my God, I have to move to Java 8. And to me, it's just a progression of us being able to invest in continuing to innovate and evolve the platform and time it in a way such that it makes sense for end users. And since we're gone from this notion of these big bang releases every few years, 6 months incremental makes that pattern of migration so much more smooth. So, for those that are still on 8, moving is not hard. It is possible. There will be some incremental adjustments, but once you make that adjustment, it is, as I'm encountering, a much more smoother ride. Ron, I didn't mean to cut you off.
Sorry, Shar, could I just add a little bit?
Sure.
I think it's also worth mentioning at the time 9 was released. There were some changes between the encapsulation of internal APIs and then some really just mundane things like format of the version string changing. I think that actually tripped up more old code than encapsulating internal APIs did. But yeah, there was a bit of a hump to get over to move past 8. My sense is that by now, almost all popular libraries, frameworks, and tools have done that move. So if you just have an application that depends on a bunch of libraries in Maven Central, if you update your dependencies, there's a good chance that you're just good to go, and you don't need to make any changes or maybe just some minor changes to get from 8 to 15.
And I think Mark gave you the technical answer. And of course, you should look up all the features he mentioned, ZGC, and I will also mention JFR and compact strings. But what this all boils down to is money, and quite a bit of money. You can save significant amounts of money by just upgrading your runtime, preferably to the most recent version. But all those changes to runtime mean that your application takes up less memory. It runs faster, it's a higher throughput. And that means that you can run it with less hardware. And that translates to actual savings.
I think that's a good point. And you mentioned compact strings. I think that's a very powerful sort of canonical example of improvements we've made over the years. So in JDK 8 and, well, every earlier version as well, we used to represent the characters of a string using 16 bits per character. And that's very flexible and allows us to store all strings, and we still need that. But it turns out that in the vast majority of cases, strings really aren't 16, using all the 16 bits. The top 8 bits are typically 0, because the vast majority of strings turn out to be not language related, like not weird characters. They're actually like boring XML configuration or whatever. So in what we did in JDK 9 was to leverage that fact. So instead of using 16 bits, we optimistically use 8 bits instead. And that may not sound so interesting and important, right? It's just like string characters after all. But couple that with the fact that the vast majority of objects on the Java heap are strings. So something in the order of 25–50% of the data on the heap is actually made up of string data, right? That turns out to in the end means that by moving up, just moving up, you don't need to do anything else. You just run with JDK 9 or later. We typically see memory savings of 10 to 25%. That's not uncommon. It's not like out there. I'm expecting if you move up that you'll see something along those lines. And that clearly is a lot of memory and in the end dollars saved.
You know,
you can probably do even better if you combine it with string deduplication.
That's right.
Which is another fairly recent feature.
Very true. But you know, one of the things as I'm hearing all of you also is, you know, as a developer, as an enterprise, as a business, I never want to be below the security baseline. And so, like, do I really want to put my business at risk? And one of the interesting things that's come from this is it's allowing us as developers to be more in tune with our application in terms of what dependencies do I have, and those dependencies in terms of libraries and frameworks, who's actually maintaining that, and are they keeping up as well? And you know, it's a discovery period. Like, what have I been doing for so many years of just taking this leap of faith that someone is actually working on these dependencies that I've been reliant on for so long. And so I think it's actually a refreshing moment that developers are much more in tune to their application versus that sort of leap of faith. So interesting questions are coming up now in terms of futures. And I know we could spend hours upon hours to talk about futures, but just in general, future pipeline, Brian, you want to talk a little bit about what's in store for developers?
So you're right. I could spend hours talking about that, but I'll try to just hit the highlights. You know, there is, as I said earlier, a mix of sort of little, medium-sized, and big features going on. You know, and you know. Things that we're planning for the short term as well as things we're planning for the longer term. So, you know, you know, the audience probably heard us talk before about the big projects like Panama, which is better native interop, or Valhalla, which is about a better relationship with memory and how objects get laid out in memory, Loom, fibers and continuations. But the feature that I'm kind of excited about from a language perspective is a slightly smaller feature, but I think going to be very interesting to developers. And it's a cluster of features, some of which we've already seen the first pieces of: records and sealed types and pattern matching. We've seen the first installments of each of those features. But the cool thing about them is how they work together to provide a sort of more data-oriented mode of programming. As programs get smaller, it used to be programs were these big monolithic things, and now we're writing a lot of smaller programs, you know, microservices, things that are closer to the boundary. industry, we're dealing with data much more that come in from outside of our program. And so we won't, we don't necessarily control that data. It's not necessarily long-lived data. And so Java needs to get better at dealing with just plain old data. And these features work together very nicely to make that easier. So records reduce the ceremony of representing data as objects. Sealed classes allow you to model, I know it's either an A or a B or a C, in the language, so that when a message comes in, you're able to reflect in the type system what kind of messages you're expecting. And pattern matching works with those two features to say, okay, a message came in, is it one of these? Okay, take it apart, let me get all the pieces out, with a lot less ceremony. And so the kinds of programs that people are writing these days, these features are a very good match for. And I think people are going to be surprised at how pleasant it is.
So I'll, as a user, I'll have to maintain less code as well.
Less code and more flexibility.
Ron, it looks like we have a question that's probably up your alley. I'm sorry, Ron, but I missed your Loom session earlier today. I'm very interested in Loom. Can you give me a little bit of context of what Loom is about and why it matters?
Cool. So first of all, if you're interested, you should watch the talk on demand. Now, many Java applications are servers, and the performance of servers is measured by how many requests per second they can handle. And the more efficient the server, then the less hardware you need. So one way of taking up less hardware is just to use the current JDK version. That's already money in your pocket. But sometimes we need to do bigger things. And the simple blocking thread per request Java code that many of us have been using since Java's beginning, and servlets, is very easy to write and maintain. And in fact, I say it's harmonious with the design of the Java platform. But it can also result in bad throughput and bad hardware utilization. So some companies just end up spending more on hardware, more than they should. And others choose to program differently. They use an asynchronous or reactive style, which is more performance, more scalable, and it saves them money on hardware, but they need to pay more in development because that style is harder to read, harder to write, harder to debug and profile and maintain. So they have a pick between spending more on hardware or spending more on development. And the reason this happens is that Java threads today are just thin wrappers around OS threads, and OS threads are just very expensive. So all those techniques trying to save up on threads or use them not very effectively. So in Project Loom, we've added an entirely new implementation of Java threads in addition to the existing one. That's not a simple wrapper around OS threads, but rather is maintained by the Java runtime. And that implementation is much more lightweight. And this allows you to write the same simple blocking code, but to get the same throughput as the people who use that complex asynchronous code. And in this particular instance, you get to have your cake and eat it too. And again, it just can save you a lot of money.
So another question that we're getting in the chat as well is, Mark, you mentioned ZGC. I thought it was experimental. What is the status on ZGC, and what does that mean for GC in general for the JDK? Maybe Mark and Michael, you want to take that one?
I'll let Michael take it. It's his team that's responsible for it.
There you go, Michael.
Yeah, so ZGC, for those who don't know it, is a garbage collector we've been working on for quite a while now. So the insight here was that as heaps or machines keep growing, heaps keep growing, the sizes of everything keeps growing. And at some point we had to sort of turn things around a bit and see how can we ensure that garbage collection runs efficiently, even for really large heaps, so terabyte-sized ones. And leveraging all the CPUs and the multi-CPU stuff that we get nowadays. And one of the things we did was to sort of turn it around a bit and say, instead of the garbage collector sort of being there in the background, having to, in a simple way, sort of reverse engineer everything that the application was doing, let's have it have the application help the garbage collector even more. So By introducing a thing we call load barrier, so a thing that happens when you load an object from the heap, by introducing that's more primitive sort of, we can do much more efficient garbage collection in the background. And that's effectively what ZGC is. So on a higher level, it is providing very, very short pause times. Our goal is less than 10 milliseconds, and we've already actually reached that for the vast majority of cases. But we're continuously working on getting that even better. So the next goal we're up against here is sub-millisecond latencies. And that's even for really large heaps. You don't have to run, or it's not just applicable for these terabyte-sized heaps. You can run with smaller ones as well, but the point is that the pause times are short. So we've been working on it for a long time. It went in as an experimental feature and help me here. We're shipping releases so often that I don't remember right now. Was it 11 we went experimental? Ballpark 11, at least. It doesn't really matter exactly, I guess. And over the years, we've gotten to the point now where we are ready to call it production ready. So with JDK 15, I'm very happy to say that ZDC is no longer an experimental feature. It's a production ready and for all intents and purposes supported feature.
It's good to finally get it in the hands of developers. They have choice now, and it's congratulations to the entire team, you, Michael, and everyone that worked on it. So long time coming.
Long time coming.
Long time coming. Mark, I have a question for you, because this oftentimes comes up, and I know it's one that I always like to ask you is, being the chief architect for Java, what is sort of like, what do you lean on in terms of how you approach innovation for Java?
What do I lean on? I lean on a huge community of very smart contributors, including some of the folks here. Not quite sure how else to answer your question, Shar.
Yeah, there's some virtues that you've talked about in the past about what makes Java so vibrant for the past 25 years that will carry it forward to the next 25. What are some of those virtues of Java that you continue to find value in?
Well, so I've always said Java has three core values. One is compatibility. The second is versatility. And actually, the third is readability, and sometimes they come out in different orders, but those are the main ones, and I think they really capture what Java has been about for 25 years and going now, and we've done very well to use those values as our guidance as we go forward, bringing Java into new application areas, upgrading Java to deal with new types of hardware. And all the rest of it. It's a constant struggle to balance conservation with innovation, but those values have stood us well, and I think they'll stand us well for another 25 years.
Yeah, I think for me, what's most compelling since we've introduced the 6-month cadence is it's about reducing latency, not about throughput. And so to me, getting things at a more predictable pace is a benefit to all developers. And I think sometimes developers get confused with that. It's like, are you shipping now hundreds of new features every 6 months? Like, no, time out. This is when a feature is done, we will put it in your hands, and this is supposed to be incremental. So it's all about reducing that latency to access versus, increasing the pipe of throughput of new features. So, my hat's off to the entire team. Mark, Brian, it's amazing what you're able to do continuing forward in terms of driving innovation for Java. Michael and Ron, it's also great to see the new features that we're investing in. Great to get ZGC across the goal line, and looking forward to seeing Loom as well doing the same. And the best part is all of these new innovation we can bring forward to you in 6-month clips. So if everyone's doing their math correctly, Java 16 is right around the corner in March of 2021. We've shipped Java 15 today. Don't forget that Java 16 early access builds are already out there. You can begin testing now. Take advantage of it. Give us your feedback. You're part of this journey. So to all of the panelists, thank you for your time. And for everyone who's watching today, thank you as well.
Thank you, Shar.
Thanks, Shar.
So thank you for sitting in on all the sessions today. There was a lot of information that was shared, a lot of content that was shared. from a lot of experts here on the Java team. Just a reminder again, these sessions are being recorded and will be available on demand. So it'll give you a chance to go back and listen to things that you want to go and get a better, deeper dive into, but also your chance to share the content with some of your peers who were not able to join us today. Now, up next in the agenda is the portion of today's event that's focused on hands-on labs. Our first two hands-on labs that are scheduled that will be running in parallel is one focused on building Java applications in the Oracle Cloud Infrastructure. That's going to be led by David Delabase. We also have another hands-on lab, both by Magic Gruska and Monica Rosselli. This is going to touch on something we mentioned earlier in the day, Project Verrazano, the notion of enterprise containers, as well as modernizing the WebLogic server. So you have the chance to go in between both of these labs. Know that capacity is limited, so pick the lab that is most interesting to you. You'll go back to the agenda, click on the lab most interesting to you, and then that will give you the chance to then start taking that course. So don't forget to go back to the agenda, do that to get into the lab of your choice. We also want to get your feedback in terms of how we're doing today overall. So this is a kind of an experiment for all of us. Oracle Developer Live is an event series we want to innovate and ensure that it is delivering the things you want to hear from. Just a few weeks ago, we did a database edition. Today is the Java edition, and in a few short weeks, we'll have an edition focused on MySQL, as well as later in November on Oracle Cloud Infrastructure. So by giving us feedback in all of these events, it allows us to innovate for the next set of events that we'll do later on, perhaps this year or even next year. So your feedback matters. Tell us how we did with the Java agenda today, with our content, with our speakers, with our format, and we will innovate and evolve our approach in downstream events. With that, I hope you enjoyed the hands-on labs, and thank you for spending your time with us today for Oracle Developer Live Java.